Creational patterns. These patterns help with dynamically creating objects at runtime. The Singleton pattern. Used when you only want one of something. Singletons ensure there's only one instance of a class at any given time, and that it can be accessed from anywhere. It starts by defining a static instance and a way to assign it, often in a constructor, an initializer method, or via lazy initialization. The instance can be made into a property with a public getter and a private setter, and an optional backing field. If duplicates are possible, you might destroy the extra ones, or use a flag to ensure persistence. You can also use generics to make a base singleton class, and leverage inheritance to hide much of the boilerplate code. Overuse of singletons can lead to tight coupling, making it difficult to scale and test code as scripts become too dependent on them. The factory pattern. Factories help you create objects, similar to a constructor. It starts by designing a static method, usually named create. The object is instantiated, and some logic might be applied to it before returning the created object. Different subclasses might have different logic applied at the time of instantiation, which can be hidden behind the factory method. Parameters can also be passed through to help determine the specific implementation of what should be created. Factories are often made for a broad base class or interface, such as spells, enemies, items, abilities, etc. The core idea is to centralize creation logic, reducing direct dependencies, and keeping your code flexible. Abstract factory. A more generic version of the factory pattern that has an interface or abstract class as its base. Specific factories are then derived from it. Abstract factories are often used for groups of related objects that go together and which share common attributes or styles. In this case, a create method is generated for each object within that family. The concrete factories then override the base method and apply specific implementation to all members. For instance, a UI might have buttons, drop-downs, and checkboxes. One factory produces Windows versions of each, while another produces Mac versions of each. Abstract factories are good for organization and scalability, but require more setup initially. The builder pattern. Used to create complex objects step by step. Its main purpose is to avoid having too many constructors, or constructors with lots of unused parameters. It does this by separating the construction of a complex object from its final product, allowing the same process to create different variations. Begin by defining an object you wish to build with a bunch of placeholder properties. Define a builder class with a constructor for that object, and provide methods to configure specific properties, like name, size, color, etc. Often, these are done as set functions. Once all the details are in place, call a method to build and return the final object. This forces construction of the object through the builder. Fluent Builder, or Fluent Interface. A more flexible form of the builder pattern that adds method chaining. Start with a standard builder, then make each configuration method return the builder itself. This lets you construct objects more intuitively, with methods such as with name, with health, with weapon, etc., all in a single line. It's a great way to make your code more readable, especially for objects with many properties, where you want the option to only use some of them, without necessarily using all of them. The order in which the object is built also does not matter, as each method is only working on a single property. The prototype pattern. Not to be confused with the prototyping phase of production, which comes between planning and testing. Prototypes focus on creating new objects by cloning existing ones. Start by defining a method in your base class that performs the cloning. Depending on your language, this might be as simple as calling a built-in method, or you might need to copy properties manually. Prototypes are ideal when creating an object from scratch is expensive or complex. An example of when you might use this would be in Character Equipment screen, wherein you have a placeholder mannequin as your visual. Rather than spawn a new character in each time, you spawn the character in once and simply copy over its clothing, weapons, and outfit from the inventory to the dummy. Unity Engine employs the prototype pattern when generating prefabs. The original object is stored as an asset, while copies are spawned in the hierarchy as clones. Prototypes are fast and efficient, but be mindful not to override your original reference unintentionally. Object pooling. Creating and destroying objects can be computationally expensive. Pooling reuses objects instead of creating new ones every time. Start by creating a pool. Usually a list or queue works best. Fill it with a number of objects to start. When an object is needed, take one from the pool. When it's no longer in use, return it to the pool for reuse. If the demand exceeds what's available in the pool, then and only then create more. Visual objects can be hidden from view until called from the pool. Additional logic might be necessary to reset variables like position and rotation, either when calling or returning, to ensure predictable behavior. This pattern is especially helpful for objects that are frequently created and destroyed, like bullets in a shooter game. Testing is often required to strike a proper balance for how many objects should be created initially. Too many can be a waste of memory, as objects go unused, while too few defeats the gains of having a shared pool. Managing the pool carefully is key to avoiding memory leaks or performance issues. Pools can also make use of generics to hide boilerplate code. Lazy initialization. Certain objects might not be required for the entire life cycle of an application. Their creation could be expensive, or their mere existence could lead to problems if not done in a particular order or at a particular time. In such cases, we delay the object's creation and setup until it's actually needed. A guard clause can be used as a stopgap the first time we try to access the object. We check if the object is null or otherwise has some default value. If it is, we create a new instance and return that. Otherwise, we return the current value or instance. Some downsides of lazy initialization include increased complexity, more difficult debugging, and hidden performance issues, as the point in time of creation is not always obvious. The Multiton pattern. Where singletons only allow one instance of a class, multitons allow several, each identified by a unique key such as a name, number, or hash ID. For a small number of instances, you can declare multiple static instances. For example, a single-player game might have a static instance of the player class, whereas a local co-op game might have static instances for player 1 and player 2. For larger or unknown amounts, multitons can be stored in a static dictionary. When a new instance is needed, check the dictionary. If the key already exists, return the existing instance. Otherwise, create and store a new one. Multitons are great for things like configurations or databases where you need multiple distinct singletons. Just keep track of your keys to avoid unexpected results. The Object Mother pattern. A fancy name for a factory that creates placeholder objects with pre-configured or default settings for use in rapid prototyping or presentation, but which might not necessarily wind up in production. The Object Mother can be useful when the focus is not on the creation of specific objects or data itself, but when object creation is needed to generate large amounts of examples to test some other aspect of the program. For instance, an inventory system might have hundreds of items, all with their own stat values and behaviors that need balancing, but we don't yet have that data, so we create a factory that produces a variety of placeholder items in order to test other aspects of the system that don't necessarily care about what specific items pass through them. They just need something in order to work, such as drag and drop, trading, or persistence. This pattern can be helpful in verifying whether the values and behaviors you get back in testing are the ones you expected. One downside of the Object Mother is that it can be misleading if your tests require very specific data in order to pass. If there are any design patterns you think we missed, let us know in the comments below. If you found this video helpful, please make sure to like, share, and subscribe so you stay up to date when we release new content. If you'd like to learn more about programming and game design, click on the link appearing on your screen now, or see the description below for ways you can help support this channel. Thanks, and take care.